Good evening to one and all, and this is Ayyappa Srinivasan MG of the Assistant Professor Triple E of Mother Teresa Engineering College. So I am here to take the take the course on electromagnetic fields and the for second year ECE, and let us start with unit 1. So the unit 1 deals with very basic fundamental concepts of vector fields. So what is meant by a vector? Hope all might have studied in your 12th standard, and a vector field is nothing but it is a vector is nothing but it is a quantity that has magnitude as well as direction, that is called vector. So in EMF there is a field called vector field, in which is a spatial distribution of quantity that may be or may not be function of time. That is, the electric field or magnetic field, whatever may be, it is distributed in space, but it is not a function. It may be not a may not be a function of time. Hope you might have studied circuit theory where DC is not varying by time. So DC field is not a function of time, but AC field is a function of time. So vector is a maybe DC or AC, and it is maybe or may not be represented as a function of time. So in a vector, fundamentally we are having two things. One is dot product, another one is cross product. What is dot product? Dot product of two vectors is nothing but A dot B, say AB cos theta. We have to multiply the magnitude of A and B both, and again by the cosine of the angle between them. Likewise, cross product is also there. We have to multiply the magnitude of A and B, and again we have to multiply it by the sine of the angle between them. In both, we are having a vector called AN, which is called as normal vector, and the magnitude of normal vector is given by A cross B by A into B. So this is fundamental thing. So we come to the main picture now. The main picture is nothing but the coordinate system, right? So there are three coordinate systems mathematically and as well as which signify physically: Cartesian, cylindrical, and spherical coordinates. So wherever we go, we can easily find the Cartesian coordinate in our house or our classroom, which has three coordinate. The one is the x, another one is y, the vertical one is z. And if you take a if you take any cylinder, right, any cylindrical object, your water bottle, say cylindrical coordinate rho signifies its radius, phi is the angle of rotation, and z is the height. Likewise, spherical coordinate r theta z, it is actually in terms of sphere, where r is the radius of sphere, theta is the angle of azimuthal angle, they will say, and z is the again the height. So let us view one by one. So it is Cartesian. We have given the Cartesian coordinate here. The Cartesian coordinate x, of course you can find it any room. In the room you can find. So the x is the horizontal one where it is shown, right? This is actually x, this is actually y, this is actually z. If we take it as a room, the one of the sides that are going in front of us in the corner is called as the, to our left or right is x, in front of us will be y, and the height will be z. So the point, any point in the xyz Cartesian coordinates is given by x comma y comma z. That means in how much distance the points are there in x and y and z. So totally the finally the point will be marked as P. Now ax vector, ay vector, az vector. It is the representation of Cartesian coordinate. So actually some people, as you might have studied in your school days, they will write it as axi vector, a plus ay j vector plus az k vector. So this may also be there. This is also right. Such things may appear in your question paper. So kindly follow this. However, in our classroom studies, this will be easier one because majority of books, including your textbook, follows this notation. The second one is cylindrical coordinate. That is, you can in this figure you can find what is rho. You see, it is the radius of the cylinder, right? And in the radius, an angle that is from the below x angle, x axis, we are taking certain angle to the point, that is pi, and the height is called as z. So rho is the radius of the cylinder, phi is azimuthal angle, and z is height of cylinder. Here aero vector, a phi vector, and az vector is its representation. So further you can find further that the one of the representations are shown in the red color. So the next one is what is called as the Cartesian to cylindrical coordinate conversion. That is, in your university examinations as well as for our real life also, we need the coordinate conversion system which may be find useful at all times. So the Cartesian to cylindrical coordinate conversion is one of the important coordinate conversion. So what we have seen in the earlier PPT is in Cartesian coordinate it is given by magnitudes are given by capital AX, capital AY, capital AZ, whereas in cylindrical coordinates the magnitudes are given by capital A rho, capital A phi, capital AZ. So we are being given with Cartesian system, that is we are given with a capital AX, capital AY, capital AZ, wherein we have to find capital A rho, capital AY, capital AZ. So there are two ways of posing this problem. One way is giving the Cartesian coordinates by points, that is given by x comma y comma z. Then in cylindrical it is rho comma phi comma z. So rho is related to x and y as well as z as root of x square plus y square. Pi is related to y and x as tan inverse of y by x, and z is nothing but once again z. In both coordinates z is same. Likewise, if we are given with vectors as we seen in the earlier PPT, it is given by a rho, a phi, az. Right? Yeah, that is we are given with ax, ay, az. We have to find a rho, a phi, az. So cos phi, sin phi, 0, minus sin phi, cos phi, 0, 0, 0, 1. Ax, ay, az. Now a question may arise in your mind, how to find this cos phi? We see the phi as tan inverse of y by x. So wherein we can find phi. Hence you have to put the phi value in this. This way we have to do. The next one is the reverse way. Cylindrical to Cartesian coordinate. Right? In cylindrical to Cartesian coordinate, a capital AX, capital AY, capital AZ. That is with this we have to find. We are given with capital A rho, capital A phi as well as capital AZ. So if we are given with this, we have to take the inverse of this vector. That is transpose of this vector. They have given us inverse. It is not inverse. transpose of this vector and we have to write. So it will be given as cos phi, this sin phi here, this 0 here, minus sin phi, cos phi, 0, 0, 0, 1. So this transformation will give us cylindrical to Cartesian coordinate. Next one is the spherical coordinate. Usually in the minds of the students, they think as usually in the minds of the students they think as the spherical coordinates is difficult one, but it is not so. So if you understand the spherical coordinate in a easier way, assimilate it in easier way, it will be easier for you. So again, r theta phi, where r is nothing but the radius of the sphere. This is the radius of the sphere. Phi is the lower plane angle, that is you have like that lower plane angle, whereas theta is in the angle of line that goes through y and z. So this is theta and this is phi, and r is the radius of the sphere. So AR vector, A phi, A theta vector, A phi vector is its vectorial representation. Point representation is given by r theta and phi. Whereas Cartesian to spherical conversion we are going to see, the capital R represents the radius of the sphere, right? Capital R represents the radius of the sphere. The radius of the sphere is given by root of x square plus y square plus z square, right? And then theta is given by arc cos, that is nothing but cos, right? Cos inverse, arc cos is given by cos inverse by z by root x square plus y square. Now in case of vector, we are given with ax, ay, az in Cartesian, where we have to find ar, a theta, a phi. So the formula is, the magnitude is sin theta cos phi, sin theta sin phi minus cos theta cos phi, cos theta sin phi minus sin theta minus sin phi cos phi 0. This way we have to write. So after this we are writing. So the theta is given here. Phi is nothing but, as we saw in cylindrical coordinates, that is tan inverse of y by x, right? So this is the thing. The next one is spherical to Cartesian, the reverse way. That is the spherical to Cartesian, that is the reverse way we are going to see. So x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, and z is equal to r cos theta. Again, theta we have seen in the earlier PPT. Likewise, this is the formula. So for conversion of spherical to Cartesian, now what we have to do now, this is the thing. Before closing and discussing about these points, I want to tell you one thing. That is, please note that these slides are important for first unit. So the first unit is fully based on 85% based on this formula. So kindly understand this formula and do the problems that are being asked in first unit. We will see in next video. Thank you.